Hey guys, today we're going to solve the riddle of what is a proportional versus a non-proportional linear graph or linear equation. The main idea is to be able to tell the difference between a proportional and non-proportional graph or situation, which would be the stories we're going to get to. This is a summary and it should be memorized. First up, they are both straight lines, so the proportional graph draws a straight line as well as the non-proportional graph. This means both of them are linear, and the key word there is line in the word linear. The proportional graph will go through the point 0, 0, but the non-proportional graph does not go through 0, 0. It will have to go through some other number on the y-axis. If we look at the table and the points in the table, proportional graphs have the same ratios. In other words, they have a constant ratio that doesn't change. And the non-proportional graph will all have different ratios between the points on the table. Interestingly, on the proportional graph, if you put the points y over x, it gives you the slope. And this is not true on the non-proportional graph. The equation for the proportional graph is y equals mx, and the equation for the non-proportional graph is y equals mx plus b, where it lists a number for the y-intercept. The y-intercept for the proportional graph will be a 0, so it would be plus 0 instead of a number, and we don't usually write that. As far as story problems, for the proportional graphs, they begin, or y equals mx plus b, begin or initiate at 0, which is their y-intercept. And for non-proportional graphs, they begin, y equals mx plus b, at some other number other than 0 on the graph. One additional thing, you should know that this m means slope in either equation. It is also the rate of change, or the rate of what is happening in a particular story circumstance. So let's put this into play with row graphs, one that's proportional and one which is non-proportional. And let's look at the differences and the similarities. First of all, these graphs both make straight lines, so they are linear. This one goes through the point 0, 0. So it's a proportional graph, and this one does not go through 0, 0. It actually goes to point 0, 0, 20, which is the y-intercept. The graph on the left, the proportional graph, also has a y-intercept, but it's 0, 0, and we don't list it in the equation. Next, let's look at the ratios of x and y, and on the proportional graph, it's 10 to 1 all the way across. It's 10 to 1. You might want to put the calculator on this one to prove it to yourself. And the ratios are all the same in a proportional graph, which is also known as direct variation. Check out the ratios on the non-proportional graph. We're listing them x over y, which would be 1 over 40, 1 over 30, and 1 over 26.6 repeating. They're all different. And so it is that in a non-proportional graph, the ratios will not all be the same. Next, let's compare the slope. And we can see from 10 to 20, we add 10. From 20 to 25, we add 5. And to 25 to 30, we add 5. And on the y side, from 1 to 2, we add 1. From 2 to 2.5, we add 0.5. And from 2.5 to 3, we add another 0.5. And if you list those as y over x and simplify them, you will find a slope of 1/10, which, interestingly enough, is the points ratio turned upside down, so y over x. So in a proportional graph, the slope can also be found by locating the points and simplifying them and putting them y over x. Looking at the non-proportional graph, we see that it goes up 1 here and here, And on the y side, it goes up 20 from 40 to 60 and 20 from 60 to 80. And if we report this as y over x, it'd be 20 over 1, so the slope is 20. Next, let's compare the equation. The equation for the proportional graph is y equals mx, where m is the slope. So we replace the m, the slope, with the number, which is 1/10 times x, and the equation is y equals 1/10 times x, and we don't list the zero-intercept. The equation for non-proportional graphs is y equals mx plus b, so we replace the m with the number for slope and the b with the number for the y-intercept. And that equation would be y equals 20x plus 20. And now let's take a look at the stories that I've made up to go with the prior discussed proportional and non-proportional graphs. First one that's proportional, I made up the story that Billy was not in good shape, but he ran the LA Marathon anyway. He ran at a pace of 1 mile per 10 minutes, and we have to stop and look at that. The word per sets up a ratio where this would be 1 mile in 10 minutes. And this would be the slope or the rate. And we're looking at where did this story begin, and he began at 0 distance. Therefore, the B, or the beginning point of this, is 0, 0, because the race began with 0 time and 0 distance for each runner. But he did proceed past water stations at 1 mile, 2 miles, and 3 miles, and he also stopped at a 2.5 mile station, which represent the dots on the graph. So this story can be represented by the equation y equals 1/10 x, and we know that it started at b, so it'll be plus 0, but we're not going to list the 0. The non-proportional graph, Billy did so well running the marathon, he decided to join 24-Hour Fitness and seriously begin training. They initially charged him $20. Initial charge, and we have to stop and look at that. This story is about charges or money, and so the money began to cost at $20, not at 0. And then Billy was charged $20 per month, and we have our favorite word per, setting up a ratio of $20 per 1 month, which is the slope. It is also the rate. The charges in this story begin at $20 per month, so that is equal to the b, or the y-intercept, or the beginning of the story. So this equation can be written y equals 20 x plus b, which is 20. So the slope is 20 and the y-intercept is 20 in this graph. Okay, I want you to do these all by yourself, answer all the questions on the page, then come back and check to see what I've done. First of all, the graph on the left is a straight line or linear, but does not go through 0, 0, so it is non-proportional. And the one on the right is linear and goes through 0, 0, so it is proportional. I will use these 3 points on my non-proportional graph. And I place those in my table, and now find the ratios. And the ratios x over y are 0 over 3, 2 over 5, 4 over 7, and the ratios are simply not the same, as we would expect in a non-proportional graph. Checking the slope, we see that we add 2 here, and add 2 here, and we add 2 here and here. So slope is reported y over x, which is 2 over 2, which is a slope of 1. So we have our slope, and we have our y-intercept we can see in 2 spots, so we can write the equation. And we will substitute in for the slope and y-intercept, ending up with y equals 1 times x plus 3. So it's y equals x plus 3. So for my story, I'm going to call the y-axis dollars and the x-axis time in weeks. And my story begins with Billy, again, opening a bank account. He began the account with $3 deposit. Then he saved $1 per week thereafter, which gives us the equation y equals a slope of $1 per week, which is 1 times x, plus 3 is the y-intercept. Okay, let's talk about the proportional graph now. As we said earlier, it is linear and it goes to the point 0, 0, so it's proportional. I will pick these 3 points that are right on the crosshairs and put them in the table. And here are the points 1, 2, 2, 4, and 3, 6. I'm going to make ratios and compare the ratios. X over y. The ratios are all the same as we would expect in a proportional graph. Now let's check the slope. The x is increased by 1 as we go from point to point, and the y is increased by 2 as we go from point to point. Slope always equals y over x, so that would mean that the slope equals 2 over 1, which is the same thing as 2. The equation in a proportional graph shows y equals m, the slope, times x. And since the y-intercept is 0, it is not listed as b. We would rewrite this as y equals m is the slope, that's 2 times x. That would be our equation. Now I'm going to write a story, and I'm going to use the y-axis will be dollars, and the x-axis will be made in weeks, just like the other story. My favorite story is always using banking. And my favorite stories also always use Billy. So I'll begin with Billy opened a bank account, period. And he did not make an initial deposit, which means that this story begins at 0, so the y-intercept is 0. He then began saving at $2 per week. And you should recognize this per as making a ratio of 2 over 1, which is our slope or rate. Just one last thing. Let's say you're looking at your table and you want to find out what the y-intercept is, so you need to find out what 0x is. Well, you can go in reverse, which this would go back. Since it's going back, it'll be subtracting 1 from 1, which give me 0x. And we can put this one in reverse too. Instead of adding 2, subtract 2. And you have 0, 0, which is the y-intercept in this case. You might want to think about that one for a moment.